After the determination of the bridge length and width, the other parameters are the slab thickness and the number and spacing of girders. Welcome to Bridge Engineering. In the computation of the slab and the girders, there are two things worth pointing out. One, the slab thickness is computed using a table of equations for the different bridge configurations. The second is the girder parameters, and unfortunately, they can't be figured out using a single formula, but on assumption and refinement. It is solved through iteration. The process starts with a determination of the bridge span using the LRFD minimum support equations, then solving the bridge width. This is started by checking on the levels of service for the highway to learn about the number of lanes. Again, the standard lane width is 12 feet or 3.65 meters. The width then also has to include the shoulders or sidewalks. Next is to assume the girder spacing. The assumption is through design experience, and from this, we can compute the slab thickness and also the number of girders. After knowing these parameters, we would need to check the structural adequacy and practical spacing, so we can check if there is a revision of the girder spacing necessary. Before diving to any example, let's dig into the nitty-gritty of the procedure. First is to compute for the bridge length. Generally, this is based on site constraints, roadway alignment, and others, where AASHTO has simplified them into allowances N. Check out the previous video on how to compute for these allowances. Moving on with the bridge width. We compute this by taking the number of lanes multiplied by the lane width, then add the width of shoulders or sidewalks. The number of lanes is computed using the levels of service, and the standard width for one lane is 12 feet or 3.65 meters. The minimum shoulder or sidewalk width is 1.5 meters, and for extreme cases, the minimum shoulder width in mountainous terrain is 0.6 meters. These are from DPWH guidelines. The next step is assuming the girder spacing S. To help out in the assumption, typical ranges include steel girders of 2 to 3.5 meters and 1.8 to 2.5 meters for pre-stressed concrete girder. For reinforced concrete, the range is from 1.5 to 2.5 meters, though RC girder bridges are less common for longer spans since they are heavier. They have lower strength-to-weight ratio and they crack under tensions, thus needing conservative spacing. The rule of thumb is that when using wider spacing, there would be fewer girders, but thicker slab. And if the girder spacing is closer, there may be more of them, but the slab would be thinner. For the deck slab thickness, the tables are based on the bridge material. The first table is for reinforced concrete, having equations for simple and continuous spans. There are also tables for pre-stressed concrete, then also for steel. From the list, it is quite noted that S is girder spacing and L is bridge length. Step 4 is the computation of the number of girders, notated as N. This is W upon S, then add 1. W is the total bridge width, and S is the girder spacing. Although seemingly simple, there is refinement needed because the girder spacing is used for the determination of the slab thickness, and it is also used for the number of girders. The number of girders helps in the distribution of load, and the distributed load affects the girder size. After knowing the size of girders, their spacing is again to be computed, which goes back to the loop of affecting the slab thickness, like the first step. The computation of the other bridge parameters is then through iteration.